what we've got here is the intake for the racer that we're making and going to be debuting on July 13th. And if you watch the other video that we were working on, you saw Matt spend hours getting this surface finish just right. And as you can see, if you get in really close on it, that is super smooth. You could put some finish paint on it and it would be perfect. But for the purpose of finding truth, which is what engineering is all about, we're going to destroy it. So a V-twin has a lot of vibrations in it when it's running, especially an unbalanced V-twin. So the first thing that we're going to do is we're going to do vibration testing on it with an air hammer, but not this air hammer, this air hammer. Air hammers are cool. So now we're going to do heat testing in this oven over here. So we just subjected this to quite a bit of destructive testing, and let's go over what actually happened and where the failures sprung up. So if you look real close in here, we printed this in two sections. So the first place to fail actually was right around the rim here of the 3D printed neck, where it attaches to the metallic base of the unit here. And in the way that it actually broke down, what we found is that probably the reason that it first fractured before we got more spirited with the air hammer was that as we were deflecting that internal disc and shocking this unit, the cone section here actually started to turn from a circle into some kind of an oblong and pulled itself away from that neck. So normally that wouldn't be that much of a problem. Again, we're more worried about the vibrations. Ultimately, when we use the air hammer at full power on the table, allowing the thing to rattle around a lot, that's when we started seeing some of the Bondo chipping off and pulling away from what was a slightly unprepared metallic surface there. Both of these joints were bonded with a adhesive from Plexus, and you can see on that second part split up there with the 3D printed part to the 3D printed part, that was the last place to actually see the failure in there. So it took quite a lot of abuse before that seam line even presented itself. And so we can see in there we made a slight collar to help to assist in the alignment of the two pieces, and that actually snapped at one point, and that probably contributed partially to that actually giving up. We can also see that the distribution of Plexus, maybe applying it in different locations, we could improve the adhesion between the two, but I think we'll probably also try and add pins in the next rev to see how that helps with the durability of the overall thing. In terms of heat, you can see at about 350 degrees Fahrenheit, it actually did start to warp. So now one side still looks pretty good, the other side totally wavy and has got a lot of bumps in it, and it's kind of tending towards what would be the outside of the bike, which is too bad. But on the other hand, the bike only gets up to, on the hottest day in Arizona at idle, sitting at a stoplight, probably about 240 degrees Fahrenheit. So the fact that this went to 350 before it really started deflecting, that's probably okay for our application. So that actually turned out pretty well.